Give it up for Jacqui and Matt.
Hi, everyone. As he mentioned, I'm Matt. This is Jacqui. And we're going to talk about a recent feature we built where we added real-time analytics, and we used Phoenix and OTP to do so. So we actually gave this talk as like a practice run at a meetup last month. Shout out to Gunther, who was there as well. And one of the questions that came up afterwards was like, who are you guys and what do you do? So, and how did you find Elixir? So we're online video infrastructure. Our first product was a data product, so quality of service analytics for people that already have a platform. And then we added an API to that recently that does like hosting, streaming, delivery, stuff like that. Our entire front end, like the front end of our app as we call it, like anything the user interfaces with directly via an API is served via Elixir. And we got there from, at my time at Brightcove, shout out to Adam Kittleson in the crowd, because he pulled Elixir into the Brightcove stack. We'd been using Rails when we built Zencoder. And it had a lot of the same paradigms, a lot of the same developer happiness tools. He did a great job evangelizing it internally. And then later when we started our own company, there was nobody to tell me I couldn't use the hipster language, so I did. And we've been using it for 3 years ever since, and it's been great. So the new feature we needed to build was something like this. If you've ever used a real-time analytics product, you've probably seen something along these lines. Different metrics, relatively large time frame, pretty standard. So our requirements from a business perspective were that we had, again, a relatively large data set over a relatively large time period, that's about 30 minutes, and then we need to display multiple types of metrics. So nothing too crazy there. The ops team told us that we couldn't kill the data store, so we were using a relatively new data store. We hadn't used it in production before. For reference, at the time, our current analytics product was typically used as more of like a New Relic style tool. So it's more historical data that a customer would log in, the engineering team would look at the data for their platform over the last week, 30 days, whatever, and then kind of use that to inform the next sprint or whatever, like use that as data to improve the product. But what we kind of kept hearing was that people wanted their operations team to be able to use the same tool, and we were roughly about 30 seconds to a minute after a view is done, that's when you would show it. So especially for live events where you might have somebody watching for an hour or two, that's not really useful for an operations team if they're completely in the dark until the event's done. So we added this real-time product. We needed to use a new type of database because our existing system didn't work. And the one we chose has been great, but we hadn't run it in production before. People were worried about what the performance profile would look like. So we wanted to really make sure that we controlled all of the interaction with that database. And also, we are not the cool kids doing hot deploys. We are Kubernetes deployments, and we like our operations team actually being able to run our app. So we need to be able to gracefully deploy, roll out, and live in like a Docker immutable container world. OK, so we were looking at all these requirements. We were thinking, OK, we already have this Elixir API. It already serves all of our client-facing API requests. This feels like an easy fit for Elixir because we also want to do real-time communication with our clients, and that is the right API for delivering this kind of data. So if you've ever built or used or conceptualized a real-time analytics product, you probably thought something kind of like this. You have a data pipeline that can be anything like a Kafka stream, whatever. You have something that does stream processing in there that can be Flink or Elixir itself, whatever, that pushes that data, after it does whatever transforms it needs to do, and the data processing, or in the stream processing part of things, it just shoves it down to all the connected clients, and you call it a day. So why WebSockets for this? I've gotten this question a couple times, like why not use servers and events? This communication isn't bidirectional, so why not just use server-side events or whatever, server-sent events? Not terribly well supported, or at least not in IE, something we needed. And honestly, more importantly, Phoenix just provides a really nice framework for working with WebSockets. So real quick, how many of you, I assume based on the show of hands yesterday, most people in here use Phoenix. How many of you are using WebSockets in Phoenix in some way? Sweet. OK, so for like the no hands that went up that aren't using Phoenix, just a quick overview of, to get on the same page, Phoenix endpoint, upgrade the connection to WebSocket connection, and then you actually do your authentication. Boilerplate from examples you see in Phoenix, you just initialize a new socket with whatever your authorization token is, connect, and then on the WebSocket side of things, you just have it in your router for the WebSocket endpoint, and then you authenticate connections coming in. OK, great. So now we have Phoenix endpoint, we've connected, we've upgraded the connection, we've authenticated on that side of things. Now we actually want to subscribe to a topic, and from there we get all the goodness of Phoenix pubsub. So again, now we have that socket that we already initialized before. We connect to the name channel that we want, and then we just join. On the server side of things, we just pattern match on that channel name, and then kick people out if they don't. So this is important later for us because we also need to do special authorization here around like making sure you're in the right org and that you have permissions to view real time, things along those lines. So we sat down, we're conceptualizing all this stuff. We think we have a model that might work, and then Jacqui went and ran with it and built what she's about to show you. So Jacqui.
Thanks, Matt. OK, so let's look again at that real-time model, where we have a data pipeline that is streaming process information to a pub/sub layer, that is then broadcasting that information to a bunch of channels that have subscribed, that then send that information to the client over WebSockets, right? Well, what if our real-time model is a little bit different, in the sense that our data pipeline isn't actually streaming process information to a pub/sub layer, right? So our problem is that we can't actually subscribe to data updates, which is a little unfortunate, because we really want to use WebSockets. But WebSockets, they work really well with that publisher-subscriber model. And without that, we might have to resort to something like polling from the client. So instead, what we decided to do was just move that polling from the client to the server, and in Elixir create a subscription process system that pulls our database for information, and then sends that information to the client over WebSockets. And that's what this looks like. Right? A user joins a channel topic. Then they just ask a dynamic supervisor to dynamically spin up a bunch of processes to pull our database for that specific channel topic. And here's just a small code example for that. After a user successfully joins a real-time channel, we can then send ourselves an after join message that gets picked up by a handle info callback, which simply just asks our dynamic supervisor to add a subscription for that particular topic. Cool. So we have a dynamic supervisor that creates a child supervisor process that then creates 4 different types of GenServer processes that are all pulling our database for different types of information. For example, one of our GenServers might be pulling our database for geo-specific information. Another might be pulling our database for time series information. Here's an example of our supervisor code. We give it a child specification with a restart property of transient, because we only want this to restart if it terminates abnormally. We wouldn't want this to restart if we explicitly terminated it. And then another value we gave was shutdown of brutal kill, which just means that when this process does die, we want it to immediately die. We don't want it to hang around for 5 seconds, which I believe is the default value. And then just on initiate, we create our 4 different GenServer workers, each one for each of our data types. And finally, we just give it a strategy of 1 for 1, meaning that if this does restart, we don't want any of the other supervisors being managed by the same dynamic supervisor to restart. Cool. And here's an example of our GenServer worker code. We give it the exact same child specification that we gave our supervisor code. We want it to behave in the exact same way. And on initiate, we just schedule a poll, which is just this process sending itself a poll message after 5 seconds have passed, which then gets picked up by handle info callback, which initiates a real-time request for our type of data, and then immediately schedules another poll. So each one of these GenServer workers is polling our database every 5 seconds for its specific data type. And we have one of these GenServer workers for each one of our organization customers. So say one of our organization customers joins a dashboard. They successfully join a channel topic. Then they ask a dynamic supervisor to then spin up a supervision tree to pull our database for their specific information. Great, we have a working system, right? No. Are you sure that this actually works for multiple users? What happens when another user comes in and joins that same exact channel topic? Well, they would actually spin up a whole nother supervision tree. So in this scenario, we have two supervision trees that are both pulling the database for the exact same information, which has resulted in both users receiving duplicate messages, which is not great. So to solve that, all we simply did was just take the processes and register them by their subscription names, which we can easily do with our supervisor start link, just providing it a name with a subscription ID. And then in our dynamic supervisor, we just say process.where is subscription ID. If it returns a PID, we know that it's already been registered. We don't need to spin up another subscription. Cool. Now everything's working, right? We fixed everything. A user joins a real-time topic. They create a dynamic supervisor. It spins up a bunch of processes to pull our database. Another user joins that same channel topic, and things are still broken. The same exact thing has happened. We have duplicate supervision trees that are both pulling our database for the same exact data. And what's actually a little bit more troubling, and this was happening before too, but it's more noticeable now, is that not only are both users receiving duplicate messages, they are sometimes out of order in terms of data. Why is this happening? So our nodes are in a connected cluster that sit behind a load balancer. And that second connection that comes in spins up a duplicate process because the way that we registered our subscription names was locally. That second node doesn't know anything about the subscription at all. So that's also easy to solve. We can just register them globally instead. And by doing that, all we need to do is provide that global atom that just registers the subscription ID globally across nodes. And then in our dynamic supervisor again, we just use the Erlang function, global.whereisName, with a subscription ID to see if it's been globally registered. And if it has, we know we don't want to spin up that supervision tree. Great. So now here's what our system looks like, right? We have two users that have both connected through a load balancer. The first user has connected to node 1. The second user has connected to node 2. Since the first user connected first, they were responsible for spinning up that supervision tree. So we have one supervision tree because the second user, when they connected, asked to see if it was already registered. They saw that it was, and they didn't need to spin one up. The second user, even though it's connected to node 2, is still receiving the messages from node 1. Things are working great. But what happens when that first user leaves the channel topic? Nothing. Everything's still working fine. That second user is still receiving messages, even though they're not on the same node. But what happens when one of our nodes dies? Especially one of the nodes that is hosting a global process. Something happens to the AWS region. I don't know what happens. Something goes horribly wrong. Well, that second user stops receiving messages altogether. Their dashboard is no longer updating. It's not good at all. So the problem that we're having is that if a global process goes down, that second user is going to stop receiving messages. We need to figure out a way to recreate that process on a separate node. And to solve that, we just utilize process monitors. So we know that if a process goes down and is abnormally killed, we're going to then just simply recreate it on the existing node. Cool. And that's what this would look like, right? A user joins a real-time topic. We ask if the subscription exists. We see that it does. Then we try and see if it exists globally or not, or on our node or not. If it exists on our node, we don't want to monitor it. If it exists on a separate node, we know that we should probably be monitoring that process. And here's an example of how you would do that. In our dynamic supervisor, we see if it's been globally registered. We see that it has, and then we just use process.alive, giving it the PID, to see if it has been monitored on our node. If it's not on our node, we know that we should monitor that process. And from a separate GenServer process, we call ours the process monitor, we just use process.monitor and give it that PID to monitor that process. And finally, we know that when that process goes down, we can check the reason to see if it was not normal. If it was not normal, then we know that we can recreate that process on our current node. Excellent. We're done here, right? Everything is working perfectly. Hold up. How are subscription processes removed? Aren't you essentially creating a leak? Yes. Right, so now our problem is that we need a way to remove that subscription supervision tree when all sockets have left a channel topic. And for that, we decided to use Phoenix Presence. I looked into a bunch of different ways to do this. The first thing I tried was, reading and writing socket, join, and leave events to something like an ETS table that can be read globally. But every time I went into a different solution, Phoenix Presence just seemed to be the way to do things. They've solved all the problems that I was trying to solve already. And I will say that that's a little bit unconventional to use on this server. All of the examples that I saw of people using Phoenix Presence were done on the client to update state, such as if, for example, you were using a chat client and you wanted to show the amount of users in a particular room. You would use Phoenix Presence to show that value. And so I haven't really seen a lot of people using it on the server, and for good reason, because Phoenix Presence is eventually consistent, which makes it really tricky to control state. But Phoenix Presence has exactly what I wanted, right? It is a channel topic registry, basically. It's replicated transparently across nodes, and it communicates over the Phoenix PubSub. So to make this work, all you really need to do in your channel module is say presence.track, give it the socket, and whatever information you'd like to track. Here's an example of some information that Phoenix Presence would give you by using presence.list. Here we have a channel topic, and then we have a list of metas, and those are just representations of the sockets that are joined on that channel topic. We have 2 in this case. Cool. So how did I make this work? Well, from a separate gen server, in our case, we'll just use our process monitor, we subscribe to a channel topic. That way, we can filter for all events that happen for that channel topic, every single message that comes through. And since when a socket leaves or joins a channel topic, a presence diff event is broadcasted to that channel. We can actually just filter for that particular presence diff event, and then use presence.list to check to see if there are any sockets still in that channel. If there's not, then we know that we can then ask our dynamic supervisor to remove that child. And here's a small example of that. So this is our GenServer process, this is our process monitor. We are just filtering for presence diff events that happen over that channel. When we find one, we say presence.list for that topic, and then if it gets back nil, we know that we can then ask to remove that particular process. And before I showed you if the reason was not normal, right? So when we remove processes, we ask our dynamic supervisor to just say supervisor.stop_paid. And the reason is normal, because normally the reason would be killed. So if we see a killed reason, we know that it was abnormally killed, and we're just going to restart that process on our current node. Otherwise, it's normal. We meant to actually remove the process. Right. And I probably blew through that, but here's some considerations.
It's almost like you talk faster when we're nervous. So.
Yeah.
So yeah, when we're looking at this, we were thinking about some considerations here, and questions that we've gotten internally or from other folks. So an obvious one, like, aren't there other ways to do this? You could just have people poll, put a big caching layer in front of everything. That'd work just fine. Sure, like, I'm sure everybody sitting here right now, taking 20 minutes, could think of other ways to do this, but this has worked really well. It provided the interface that we wanted to our customers, and we were able to control all of the communication with our service without any external dependencies and less than like 500 lines of code, which is great. That's what we wanted. And we got to build something fun. As Jacqui pointed out earlier, like, isn't Phoenix Presence eventually consistent? So this seems like a bad fit. And honestly, it's fine. We only rely on it to let us know when a topic list is empty. And then we know the node hosting our subscription process will eventually and quickly be given that information. And on that note, do process removals always work? Yes. So a vast majority of the time this works. We haven't really seen any serious issues here at all. But we were just able to build some really light tooling to make sure that we are notified and remove any zombie processes that happen. So far, this hasn't happened in production. that I know of. So yeah, what about the race condition when? Sure, I'm sure there are a few more, but a common one that we get asked about is what happens if some scenario happens where you, like, at the exact same time, two people register, global process registers, or for some reason nodes were disconnected for a second. This is totally fine in our case. When Erlang, the Erlang VM, when OTP sees that you have two duplicate global process names, it'll just call the resolver function, which for us the default was fine, and that's just, it'll pick a random one and kill it, which is fine. And then everybody's connected to the other node, and the system carries on as expected. So yeah, we'll be around to hang out, and I'll show you guys the dashboard real quick. But if you want to chat about anything, Jacqui's an enigma on the internet, but you can find her in person. So real quick. So this is what the dashboard ends up looking like. This is in production right now running. So if the internet's actually working, which it might not be,
It doesn't look like it.
you should see this. Let me try refreshing.
Yeah, it's not gonna happen.
Yeah. So one other quick note. We were talking about this yesterday when, or this came up in like a one-on-one conversation with somebody around interacting with Docker and Kubernetes, things like that. Meant to mention this earlier. But if you haven't used it, a really great tool is Observer, but it can be kind of a shit experience when you need to connect to that node through everything else. Like getting an Observer running in a Docker container running in your Kubernetes environment can be a pain. And we've actually had a ton of luck with Observer CLI. That was really, really helpful when we were working on this. So if you struggle, and if you are in a Docker world and you struggle getting Observer connected, I highly suggest checking out the Observer CLI stuff. It'll let you just SSH into the box. As long as you can exec into the container, you can run it, and then you get all the nice debugging tools. And admittedly, a crappier interface, but it works. Cool. Thanks, everyone.
Thanks. Do we have any questions? You gonna come over here? Over there.
I'll do. Jacqui, so you pull the database every 5 seconds. So you store the data in the database, aggregate it there, instead of aggregating it within Elixir, for instance, and just storing the data as it is probably time series data in the database. Is that correct?
Yeah. So our particular database does especially well with aggregation.
Okay.
That's one of the reasons why it's so unique.
And the other question I had, sorry. So you have to push it out, this aggregate result, you have to push it out to, let's say, 1,000 clients as soon as every 5 seconds?
Sure, yeah.
Okay, is there any sort of back pressure mechanism if it takes longer than those 5 seconds?
If it takes longer than those so they're all separate processes that are pulling and sending it back. So if it does take longer than 5 seconds, we're pulling for the same information in our particular use case. We're pulling the 30 minutes each time. So it would just drop it. It doesn't matter for us, but I can see how that could be an issue for other types of use cases.
There would never be missing data. It would just, because we pull the full data set down for the 30-minute window, you're not going to get any holes. If something backs up, it'd be fine.
It's my turn. I'm curious if you have any sort of benchmarking or measurements around this, specifically like how many database connections that you're handling in production, and if you've seen any latency or cause or with a certain amount, or even the presence data. I'd be interested to learn like how big of a presence stack are you monitoring and replicating across this cluster, and if you notice any changes based on how many clients are connected or how many users are connected for it.
So that's something that I really wanted to get around to. Right now, we don't have like a ton of customers. It's an enterprise product, so like we have like maybe like 100 right now total. But this will be something that we do want to scale up. And the one thing that I really wanted to work on that I didn't get to yet was writing some sort of like benchmarking tool to actually just scale that up to see. Because I know that, for instance, it was mentioned yesterday, registering something globally on that global name register can become problematic when you have a lot of them and replicating that across nodes. So I'm actually curious myself to see how well that would scale. And also for the presence information too, especially since it is replicated across nodes. So I don't really know yet. I'm sure there are problems. For us, we're not going to run into that just yet. We might never, but it's definitely something to think about if you are going to do something like this.
So far, it's just been pretty smooth sailing.
Yeah, it's been great.
Great. Well, wish we all had that.
To be fair, it's feature gated in our most expensive plan, so it's,
Yeah.
you know, the number of people using it is small enough that it hasn't been a concern yet.
Let me get here and then I'll come back to you.
Great talk. You guys talked about you were on a previous database before that didn't work very well. I was curious what that database was and also what database you guys are on now.
Sorry, I might have misspoken there. The old database worked great and is working great. It's just sharded Postgres where we do our own manual aggregation. And that's been great. That's fine for our historical product. There haven't been issues there, aside from it being a big, complex Postgres system. This database was just much better suited for this exact scenario where we have a shorter time frame that we can keep in there, and it does really well with the aggregation. And what we haven't gotten to yet in the product is filtering, like being able to add arbitrary filters and just query it without having to pre-prepare data like we do right now in our aggregation step. We're not publicly talking about what database we're using quite yet, but it's been on Hacker News a few times in the last few weeks. If you just grab me afterwards, I'm happy to talk about it. We're just like not saying it in front of cameras quite yet.
Okay, cool. Thank you.
Oh, okay, cool. Oh.
How did you test this?
How did we test this?
Yeah.
Well, so I went through this great process of getting Docker to work with libcluster, which is a great library. And so basically on my local machine, I'm spinning up two nodes, and I tested it that way. Obviously, I also wrote unit tests for it. But yeah, I did a lot of local testing between two nodes and like multiple browser tabs open. Again, the one thing that I really want to get to is some sort of like scaling benchmark tool where I can actually test this really well. But again, for our really small customer use case, like my local tests were really good. Yeah, this could be really bad for a lot of situations. I'm very sure of that. But for us, it worked really well.
Thank you.
To be fair, this also, I was hoping and praying that one of the talks yesterday would solve this problem for me. But yeah, what we'd like, we're using Docker Compose. What would be amazing, we were sitting here looking at we were having to copy and paste our app description in our Docker Compose file for as many times as we wanted to run it and then kind of manually add things to libcluster. It was a real big pain. Would have been great if we could have just run Docker Compose scale 20 and then see what happens when we ran 20 nodes. But unfortunately, we could not get libcluster to play nice with Docker Compose arbitrary files or arbitrary containers. If you know how to solve that. Okay.
Yeah. And the other thing we used to really test it was Observer CLI, which I think most people use the other UI for sort of looking at the Elixir processes that are running. But Observer CLI was great for Docker in particular. You can just see it's just a command line terminal. You see all of the processes. It was really good for debugging.
So you mentioned that you were using Phoenix Presence on the server side, and that's not usually a common thing to do.
Yeah.
Is there any particular reason beyond that, and did you have to do any particular retrofitting in order to make that work? that we should know about? Or?
What was?
If I heard you right, you were asking, she mentioned that it's used mostly on the client side,
Yeah.
and why is that, and is there a concern?
Right.
Is that?
Yes,
Yeah.
there is definitely a concern. So presence is eventually consistent. So things might not appear the same on every node, which would be really bad for keeping track of state. And it's really good for like things on the client where, again, if you have like a chat room and you want to like see the amount of users, you can see like how many sockets have joined this channel, and that number would update. It might not be right all the time, but it's fine, right? The reason why it's bad is that there could be a potential race condition, especially when somebody is in the process of removing. Everybody's left that channel, and then somebody has now joined, and there's this race condition where when the process is being removed, somebody is joining, it doesn't see it, and then that person will then not see any updates at all, right? I can get around this by just implementing a interval on the client that just says, if I haven't had data for this amount of seconds, then rejoin again, and then it would spit up a new process. But yeah, that's why it's not really great for the server right now, is because of its eventual consistency.
Thanks.
You had mentioned that you use Docker Compose locally, and you would love to be able to scale up. Have you ever looked at running Minikube? And did you have any luck with it in that scenario, right? Because I don't know if it supports libcluster and all that with Minikube, but I was just curious on your thoughts.
Yeah, great question. This actually came up yesterday when I was chatting with somebody about this. We do use Minikube for other pieces of our infrastructure locally. The issue there is Minikube is just big and clunky and annoying to work with locally, honestly. So we haven't tried it, or we didn't try it for this specific instance, but theoretically it should be fine. We'll let you know when we get around to trying it. But like melts my laptop at least. So.
Cool. Any other last questions? All right. Thanks, Matt and Jacqui.